And now lastly, suggest a graph which could be drawn. Okay, so in this case, right, you only got two things, which is your masses and also your force. So normally your x-axis will be the independent variable. So you got your masses over here in maybe kg. Then your y-axis, that will be the force needed. Then you put it in Newton. Okay. Now in a lot of the cases, they would ask you to show a table or so. Okay, so if they didn't say draw a table, you don't need to. But if they ask you to draw a table, you just sketch roughly how your table will look like. So in this case, I only have a few readings. I have my masses in kg. Then another thing I measured is the force in Newton only. So your table will look something very simple like this only. Okay? But inside your table, you should record down anything that is in your procedure. Any measurements that you have in your procedure, you should include it in your table if you got drawings. Okay. No, you don't need to draw a line for the graph because they are just asking you about what graph they can draw. You haven't do the experiment, so you don't have data. Okay. So yeah, you can screenshot it already. Alright, so yeah, with that, once you answer all the questions right, then it should be enough for you to get the 7 marks. Okay. Yep, so far anyone still got question or not? Now, if no question, we still got a little bit of time. So I will be going through like what are the safety precautions, all those things that you can have. If table or graph, I don't need to put value. Yeah, correct, Janelle. You don't need to put any readings on your table because you haven't do the experiment. Okay, so yeah, let me give you guys all these things. So tips wise, actually, not much tip I can give you guys, but just follow the instruction. But then, yeah, over here I will give you guys some common questions that they usually ask. Can I say repeat experiment for 2 more times and obtain the average value? Yeah, Yu Yang, yes, you can do that. That's what we did on the last point. Is there any specific method to plan the experiment? No, there's no specific method, but you need to make sure that your experiment is makes sense. Like you manage to investigate what the question is telling you. Okay. Also, can we write anything in point form? I don't recommend. I recommend in paragraph form. But then, if you want to write in point form, the marking scheme didn't say they will minus mark. So I still recommend paragraph. Okay. So now let me go through some of the improvement or the accuracy with you guys. Okay. Now, when we are talking about accuracy improvements, right? There's a few categories that we can actually talk about. So the first one is every time you have measurements. So measurements like using your ruler, your thermometer, all those things, right? If they ask you how can you take an accurate measurement, you can mention about the parallax error. So you want to avoid parallax error by making sure that your eye level is constant. So like this one is your scale. I already mentioned just now, make sure your eye level is perpendicular to the scale. Okay, so these are some accuracy improvements we can have. Okay, then after that, if the question asks you something related to circuits, right? Okay, so circuits usually they will measure voltage and also current one. Okay, so if we wanted to have a improvement in our answers, you can actually tell them to use smaller currents. Okay, now the reason of using smaller currents is actually to reduce the temperature, because temperature will actually affect your result. Okay, then another thing you can say is actually to off the circuit after finish taking measurements. Okay, so yeah, these are some improvement you can have if you are talking about circuits. Andrew asked me what is a meniscus. Okay, meniscus is basically the water level. So like, let's say this is your test tube. When you are viewing the water level, right, you'll see that your water will dip down a little bit, horizontal. Then after that, it goes back up again. So this flat line that you see over here, right, that is actually your meniscus. Okay, so you need to read from this meniscus. Why use smaller current again? Okay, smaller currents here is actually to have lower temperature. Okay, because when you use too high current, your wire will get heated up, and that will affect your results also. Shouldn't it be off the circuit when taking measurements? After you take measurements, because like you're taking measurement that time, you need to have the current inside. Okay, or you can set off the circuit after finish taking measurements in between turns like that. The temperature increases when resistance increases, right? Yeah, correct. Resistance is affected by temperature. Actually, it's temp increase, resistance increase. Okay. Now, the next one is improvement about your ray diagram. Okay, now the ray diagram that I'm talking about here is when they ask you to draw for reflection and refraction, all those things. So like, let's say this one over here. Refraction means something like this. And then reflection, it will probably be, this is the mirror. Then you got your light going in this direction. Okay, now in this kind of situation, they like to use pins. Okay, they will use pins to place it on the paper first, then only you draw the lines. So when you are pressing the pins, right, you must make sure that all the pins, they are as far away as possible, at least 5 centimeters apart, then only it could be accurate. So for the improvement over here, you can tell them to place the pin far apart. Okay, so that's one of the improvement. Then after that, another point for improvement is something related to your pencil. Okay, now the experimental procedure is actually you place the pin first. After you place the pins, right, you use your pencil and then you draw a line in between them. So when you are joining the lines between them, your pencil over here need to be as thin as possible. Don't use very thick pencil to sketch. So you can set improvement, use thin pencils or thin lines. Okay, can you please move above? Okay, sure, no problem. So like that. Okay, oh, it's 11:30. I think I can still extend for maybe 5 to 10 more minutes. So I finish all the accuracy first. So ray diagram is here. Then next one, we got something related to your heating or cooling one. So for improvement of your heating and cooling, probably you can tell them to add insulation. So, okay, like just now the one we do. So add insulation, the purpose is to prevent the heat loss. Okay, so preventing heat loss will let your result be more accurate. Then besides adding your insulations, sometimes your beaker or those have a very big opening to it. So you can set cover with lid also. Okay, it's also to prevent your heat loss. Okay. Then after that, I write it at the side here. Okay, the next one is something to do with your lenses. So I see just now they asked me what are the improvements for your lenses. So for lenses over here, every time we actually have a lens placed at here and then your object somewhere around here. Okay. Now for the improvements, right? What we need to make sure of is that this lens over here must be perpendicular to the bench. So that is one improvement that we can have. Another one is you tell them to carry out the experiment in a dark room. So this too should be enough for your improvement of your lenses experiment. Okay. Then lastly, they could also ask you to how to check something is vertical. Okay. So if we wanted to make sure your meter rule and everything is as straight as possible, you will need to use your set squares. Okay, so the way we use set squares is not that difficult. Let's say this is the land, okay, then your ruler might be somewhere around here. So you need to use your set square to make sure that your ruler is as straight as possible. Okay, sure, Lian, no problem. If it says improvement for reducing cooling rates, yeah, correct. You can add insulation also. It will reduce cooling rates. Can you list down an example of insulation? Can. So insulation, you can say cotton wool is a very good insulation. Other types maybe is your. Let me think. Yeah, actually cotton wool is enough. You can say like nylon or any type of insulation is okay. Newspaper not that good. Use those common one. Cotton is good. Plastic also can. Oscillation, accuracy and improvement. Okay, can. If you guys are talking about oscillations, right, like your pendulum and all those things. So pendulum, you are measuring the period and all those things. So to calculate the periods, you don't just let them swing for one time, you know. You want to make sure that they swing as many times as possible, then you get the average. So swing for multiple times and get average. So that will actually help you reduce your error. Okay, set square is used in what condition? Set square is used when we wanted to make sure your objects are straight. Like your ruler, you want it straight, you can use your set square. Another one is to measure some length also can. So for example, if I have a ruler over here, okay, and then I have a circular object like this, and I wanted to measure the diameter. So what you guys can do is you can place two set square at the sides. So you put one over here, you put another one over here. So when you are reading, you read this intersection parts. Then those two would be the diameter in between. Okay, so yeah, these are all the improvement that I can tell you guys. Any more questions from you all? If you guys want to screenshot, you can. For diameter, can we say wrap a rope around the object and measure the length of rope? That one is not measuring the diameter. That one is measuring the whole circumference of the circle. Because like, if you imagine your sphere is like this, So when you use a string, you wrap it around, and then you are technically measuring the whole circle itself. So that's the circumference. Divide by pi. Technically, yes, you can, but try to use a more straightforward method. So, can I put ruler beside the pendulum to increase the accuracy of the results? You put ruler at the sides. Let me think. It doesn't really improve accuracy though. You must explain to them how you use the ruler. What is used to measure diameter? Okay, measuring diameter for small items, right? You got your vernier calipers. Okay, so vernier calipers is the instrument we use to measure something small, like a ping pong ball or those stuff. Micrometer screw gauge is actually can also, both are accepted. Okay, but then micrometer screw gauge will actually be like even smaller. Vernier calipers can measure something larger than micrometer screw gauge can. Okay, yeah, these two can still help you measure diameter. Do I need to add equations in experiment and will I get a mark for it? If you are talking about the procedure, yes, sometimes you need. So for example, like the experiment asks you to calculate the speed of the person. Then in your procedure, probably you will tell them to measure